Okay, so number 4. I factored this denominator, so like if you can factor it, factor it. So that's no longer x squared plus 3x, it's x times x plus 3. Same thing, but this way it's a little easier to see what individual factors we have making up our denominators. Okay, so there's only one factor making up this denominator, x plus 3. There's only one factor making up this denominator, it's x. And then there's 2 making up this one. So we have to multiply by each individual or each unique factor that's making up a denominator. So we have an x, so we multiply all of them by x. And biggest thing I think is to make sure that the x plus 2, the whole thing is being multiplied by x. If you were to have to multiply that out, you'd have to distribute the x to the x and the 2. And I think a lot of people are skipping that. But once you do that, you see an x here and an x here, so those cancel out. You have an x here and an x here, so those divide out. Now I'll rewrite what we have. So all we're left with in the first term is a 2. X plus 2 over x plus 3 equals 3x over x plus 3. So by multiplying by x, we got rid of half of our denominators. And now let's get rid of the other half. X plus 3. So this one and this one, and this one and this one. Times x plus 3 minus x plus 2. This is what got everybody on number 4, is this minus sign is basically distributed to both of those. So if you don't do that, you'll end up with a positive 2 instead of a negative 2. So let's multiply all this out. 2x plus 6 minus x minus 2 equals 3x. Combine some like terms here and here, get x, and here and here, get plus 4 equals 3x. Subtract x from both sides, get 4 equals 2x, divide by 2, x equals 2. Fly. Okay, again, factoring denominators if you can. So we have a common, these have a b in common, so we factor out a b. We're left with b minus 5. And we look for our individual factors. We have a b, and then we also have a b minus 5. So that means we need to multiply by both of those things. Times b everywhere, and we'll have a b over a b. We'll have a b over a b. So we're left with b over b minus 5 equals 5b minus 25 plus 1 over b minus 5. Then we got to multiply by our b minus 5 everywhere. Making sure to know that the 5b minus 25 and the b minus 5 are in parentheses. So you got to multiply, you got to distribute all of that out. Those b minus 5s, those b minus 5s are gone. We're left with b equals 5b minus 25 times b minus 5 plus 1. Multiply this all out. 5b times b, 5b squared. 5b times negative 5, negative 25 times b, another negative 25b, and then negative 25 times negative 5 plus 125 plus 1. Then we got to combine like terms. And since we have a quadratic, we want to get everything on one side so that we can either factor, graph, or use the quadratic formula. So let's subtract the b. Then we'll have nothing equals 5b squared minus 51b plus 126. So from here, you could try to factor it. I happen to know that it's going to be tough to factor, so I would suggest graphing because I think it's the fastest. So let's pull that up. 5b squared minus 51b. Looky there, I already got it. 5x squared minus 51x plus 126. So you graph it, and there's your two answers. Do you know how to find zeros?
Isn't it second math, there's second trace, and then it's 2?
Second trace 2, and then you got to go, so it says left bound, so you put the cursor on the left side, hit enter, put the cursor on the right side of that 0, because we want to know this point, so we got to put on both sides and hit enter twice, and it'll tell you, so one of them's 4.2, and then you got to go and get the other one, second trace 2, enter one time, enter 2 more times, and it tells you 6, so 4.2 and 6. And if you wanted to, you can convert that to a fraction, 4.2. So that would be 21 fifths. And your calculator can do that one for you too. 4.2 math to a fraction, 21 over 5. And then it's not the case on this one, but sometimes if you plugged one of those answers back into your original problem, you would see that the denominator became 0 at some point, but it doesn't on this one. So 6 minus 5, that's fine. 6, that's fine. And then that would be 36 minus 30. So that's okay. So both of our solutions work. They're not extraneous or anything. All right, let's. This is number 12, and I know that I have not worked at all, but I wanted to at least get a visual up there so you could check through your work and see if you missed any steps. When you get to this point, I'm going to subtract an n squared from both sides. And what happens is both of those n squareds go to 0. And all I'm left with is 8n plus 12 equals 4n minus 6. Subtract 4n both sides, you get 4n plus 12 equals negative 6. Subtract 12 from both sides, 4n is negative 18. Divide by 4, you get n equals negative 18 over 4, but that can simplify to negative 9 over 2. So you're done. All right, I'm going to do the work problems. That way you can see those. So we got the force, the gravitational force on an object is given by a formula. M is the mass of the object. E is the distance between the object and the center of the Earth. So we need to write an equation describing the gravitational force that the Earth exerts on a 950 kilogram object. So that would be the force is 4 times 10 to the 14th times the mass of the object, 950 kilograms, divided by the distance between them squared. That's all that is. And then use that equation to find out how far away the Earth and that object are if they have a gravitational force of 200 newtons. So 200 is the force, and that's equal to 4 times 10 to the 14th times 950 over d squared. In keeping with what we've been doing, we have one denominator, it's d squared. So we'll multiply it by d squared. Those d squareds divide out. We are left with 200d squared equals 4 times 10 to the 14th times 950. Divide by 200. And we get the distance squared equals whatever that is. Let's go to the calculator. 4 times 10 to the 14th power times 950 divided by 200. And then we'll take the square root of that. And it gives us 435,889.89. And if you want, you can write that in scientific notation. So I guess we would have a positive and a negative, but you're not going to have a negative distance. So let's write that in scientific notation. 4.36 times 10 to the 7th meters. That's the distance. Last one. This one. It's a word problem, and it's not as hard as it looks. Not as bad as it looks. We're talking about the focal length of a camera. And we have two distance between the lens and the film, and the distance between the lens and the object. So 1 over d naught. Well, it tells us what d0 is. It's 20. So we can plug that in. Plus 1 over di. That would be the distance between the lens and the film. And it tells us that's 30. Equals 1 over f. So, not as bad as it looks. Let's just multiply by 20 everywhere, because that's a unique denominator. Those 20s will cancel out. We'll have 1 plus 20 over 30 equals 20 over f. Now let's multiply by 30 everywhere. Just some of them, all of them. These 30s divide out, but we are left with 30 plus 20 equals 600 over f. So then we multiply by f everywhere. That's not the same f. 30f plus 20f, that's 50f, equals 600. Then we divide by 50, we get that the focal length of the lens is 12